Welcome to Entrepreneur Hour. I'm Julie Roll. I'm joined by my Energy Futures Lab colleague, Aaron Romanchuk, and we will be your hosts for today's session. What an honor it is to be here in Mohkinstsis, which is the Blackfoot word for Calgary, if you're not familiar with that. What a great pleasure to be on Treaty 7 and to walk the lands that have been stewarded by many nations for countless generations. So Aaron and I are from the Energy Futures Lab, which is an Alberta-based innovation network, essentially, and collaborative action group. We come together to build projects that are aligned with our 2050 vision. And so we're really excited to be here today to hear about some projects that are on the go that help contribute to our energy future. And come talk to us after if you're interested about who the EFL is. So we had the good fortune of meeting these three entrepreneurs last week. This is going to be a really energizing, vibrant session, so we're really excited about that. If you could put up the slide, we're going to do questions on Slido today, but it won't be on the main Energy Disruptors Slido. We've got a different kind of breakout Slido, so you can do this QR code or the hashtag EDU breakout. That's for just this session today. So please capture your questions as we go, and hopefully we'll have a few minutes at the end to answer some of those questions, so we'll try to keep it moving. So first up today is Mike Tourigny. He's the Chief Operations Officer at Acceleware. Mike hopes that as we move forward, we can get past partisanship and start looking at the system as a whole. He's where he is today because of a transformative experience that he had with the team at Acceleware when they realized the true potential of the technology that they had developed. And I'll let him tell you more about it now.
Thanks, Julie. Hello, everybody. Thanks for your time, for being here today. I'm going to start off and say anybody who's been involved in a startup, a new tech development company, or that kind of environment will understand that I had better plans to not have my script in my hand this week. But I'm going to use that for a little bit of reference as we go through things. So thanks for being here. So the key theme for my talk today goes back about 5 years. My wife and I were sitting at the dinner table with our kids, and we happened to be a rare occasion, but we were talking about news and climate change, world events. And my stepdaughter said, well, none of that really matters. The world's going to blow up in 50 years. This isn't going to work. And we were pretty stunned. So we sat there in silence for a few minutes, looked around the table, asked my son, do you agree? He said, God, yes. So we were pretty floored and realized two things. Number one, hopelessness. So our kids, their peers, and that generation, their opinion on the state of the world and what can be done is way worse than we thought. And number two, we were doing a pretty bad job of communicating what we do every day at work to our kids. So since then, we've improved that. We've talked to them a lot more, and we see now they have some hope. They're still concerned, but they see hope. They see that technologies like ours and others can really bring some material change into the world and help. So that leads me to what I'm here to talk to you about today. So Acceleware has an audacious goal. If you can read this, you can see that we want to be a global leader in decarbonizing industrial heating. So we're going to accomplish this through a technology we've developed that we call the Clean Tech Inverter, or CTI. And I'm going to start out with an analogy in the energy transition space. I'm going to use an analogy of Tesla. So Tesla's a great example of electrification. They're helping make the shift from a combustion engine to an EV. In doing that, they're getting rid of emissions because they're stopping the use of fuel, but they're also driving up efficiency in a massive way. So going from a combustion engine sitting around 30% energy efficiency to an EV at over 80%. And we think that's fundamental to the entire cause of the energy transition, to make sure we're doing things efficiently, not just cleaner. So when we look at something like that example, the transportation sector, we've got a pretty climate change aware group here, and I think we all know transportation's a big piece, but maybe it's a quarter total of our global emissions. Other pieces cover 3/4 of that pie. So industrial heating, what we're talking about today, it runs a thread through all of those sectors, really. So I'm going to give some examples for context here. Things like crop drying and bulk solids drying. If you think of things from every slice of bread you eat, every grain product, corn product, dog kibble, cat kibble, protein powder, supplements, all those food products need drying before they get to market, and they need drying coming off the field so that the yields go up and we can continue to produce the volume of food we do today. Another example is commercial building heat. So if you think of any hospital, school, office building, or a big facility, they all tend to use coal, gas, oil-fired boilers to deliver heat to those facilities. And the last example I'll give is industrial processes. That can be anything from mining to steel making to concrete to glass fabrication. All of them need massive amounts of heat to run those processes. And that heat, so far, mostly comes from combustion. That's heat that we can efficiently electrify. And again, efficiently is a word I'm going to come back to throughout the talk. We can not only replace the fossil fuel combustion, but we can typically cut the energy input in half. So similar to the EV and Tesla, we can reduce the cost and energy inputs while eliminating emissions at the same time. So that's a pretty big space when you think about the 3/4 of the emissions around the world that touches. So I want you to think about that, and we'll keep going through the examples here. So I've talked about us eliminating emissions and using this clean tech inverter. So what is it? So the clean tech inverter itself is a patent-pending radio frequency energy heat inverter technology. It's an engine, electrification engine that can provide reliable and scalable heat. It can run on demand, and it can support intermittent power sources. So when we talk about a lot of these sectors, they make the list of hard to decarbonize sectors. We can decarbonize those, put in cleaner energy, and displace that fossil fuel combustion heat. Another major application is that we can produce hydrogen from pyrolysis, also color flavored as turquoise hydrogen. So we think that integration of RF energy into the pyrolysis reaction could drive the most efficient and scalable hydrogen production around the world. We recently announced a collaboration with Aurora Hydrogen out of Edmonton to integrate our clean tech inverter energy with their reactor technology. Again, we see this driving the lowest energy input, lowest cost hydrogen, period. It's something that, because of the flexibility of the electronics, it can scale up or down. It can operate on a distributed or centralized basis. So I know there's a wide range of opinions on what the hydrogen economy will or won't be, but regardless, there's a big role to play for hydrogen, and we think we can be a part of that. So the clean tech inverter can deliver heat to all of these things without fossil fuel combustion. Like Tesla and the EV, the CTI can offer a lower cost, more efficient path to net zero. When we look at all those threads and all those sectors that we touch, when we add those up, we think that covers roughly 50% of global emissions today. Now, I'm certainly not saying we can take that all down to zero, but if you look at each of those slices and every place where you're using fossil fuel to make heat on an industrial scale, we can decarbonize those processes while also reducing costs. So a big factor is on the adoption side. There are electric technologies in a lot of those spaces that could be used, but they don't tend to be because gas burning is cheaper. We can put less energy in and lower cost than gas burning. So I'm going to shift to why the CTI is novel. So we developed this technology with GE Global Research. To our knowledge, there's nothing like it in the world today in terms of scale and efficiency. We can operate at over 98% conversion efficiency of electricity in to RF energy out, and then delivering that into any of those processes or reactions. That energy is only turned into heat when it hits the material we're trying to heat. So very low losses and very high efficiency. It can run on intermittent power very easily. It's more like a dimmer light switch. You want it on high, you put it on high. You want it on low, you put it on low. That's great for the use of renewable power. It's also great for the greening and balancing of the grid, allowing people to put lowest cost power into low value processes and save the high value power for peak demand off the grid. Again, efficiency is critical, so that's a piece I want to keep coming back to. Being able to operate efficiently, deliver that energy where it's needed and when it's needed is key. And a staple is not my best idea. So how did we get here? How did we end up with the CTI? Interestingly enough, our journey started with an effort to use RF energy to cleanly produce oil sand and heavy oil deposits. What we expected to take 3 years in that space has taken 10, but we are now in a pilot with that technology up near Lloydminster, Alberta, proving that we can operate this technology. It's been running for 6 months straight, and it's going to deliver that kind of efficiency and potential for emissions reduction. It uses zero water, zero solvent, and of course, as clean as that power source is, that's how clean that heavy oil production could be. While that project continues, we believe it's very important, we're now excited to work on these other CTI applications in drying, heating, and hydrogen production. So, back to decarbonizing industrial heat. That's what we're about. We're passionate about decarbonization. And we don't want to just bring hope, we want to bring material results. We want to help in Alberta and Canada, but we want material results around the world. Today, I'm hoping to get your help. So, the energy transition, I think you would maybe all agree, can be confusing, nebulous, and daunting. We've been working on this for 10 years. We'd like to say we've tried every door, we've pushed on every elevator button, every meeting we can do, and we all have flat faces to prove it from running into brick walls. But we're still here, we're still going. And what we're trying to accomplish is to push transformative change. So big companies tend to be slow. They move slowly. Small companies can be nimble. They don't have the funds to invest. But we're trying to break through those barriers and drive transformative adoption of innovation like ours. So here's where I'm asking for your help. We were able to get our kids to open their minds to a little bit of hope. And what we're looking for today is to turn this into a bit of a flash mob of networking. So we hope that if you like our story, you can talk about it with other people you see at the show. You can talk about it at work. You can make introductions to people you know in industries you think might have a need for this kind of technology. You can even bring it up and talk about it at the dinner table or with friends or family, because who knows what any one of those discussions might bring to elevate the potential of this kind of technology. So thank you very much for your time. Hope you'll check us out. If you'd like to learn more, come and talk to me afterwards. Check us out on LinkedIn. Follow us there. We're a public company. Ticker symbol AXE on the TSX Venture, so you can learn about us there, and on our website, acceleware.com. Thanks for your time today.
Thanks, Mike. Wow, a flash mob of, what did you say, networking energy? That's great. I feel like I heard Bill Whitelaw refer to your technology once as microwaving bitumen, so maybe that's something that could catch on too. Next on stage, don't mistake him with Will Smith, is Bill Smith. Although I have heard that that's happened once. So if you want to catch up with him in the Hive, you can hear about how he came face to face with the Fresh Prince's sneakers. So Bill's the Senior Vice President of Operations and Engineering at Terrestrial Energy. His hope for the energy transition is that we can extend the luxuries of the West to the rest of the world through emissions-free sources of energy. Let's hear how he hopes to do that.
Thank you.
Welcome, Bill.
Thank you. Hello, everyone. I'm here in Alberta and I've been here for 2-3 months off and on to dispel myths of nuclear. So first myth, nuclear and entrepreneur do go together. So I've tried to demonstrate that today, if I may. So thanks for coming. Look forward to a nice little chat, and I'm here to dispel myths. Any pro-nuclear folks in the crowd? Hey, any antis? Yeah, good. Yeah, we'll talk afterwards. Fantastic. And by the way, as you can tell, I can remember when the Rolling Stones weren't rolling, by the way. And that leads me to sort of trace the history of nuclear. Back in 1953, President Dwight Eisenhower was addressing the United Nations General Assembly, as President Biden is today, coincidentally. And he was talking about atoms for peace to sort of dispel the scourge of the atom and try to give societal benefit to same. As he said, to demonstrate the miraculous inventiveness of, well, he said mankind, I'll say humankind, and to show that I'm a little bit more modern. And that led to some development in nuclear. But it extends back to, a couple of hundred years ago when a German chemist discovered uranium. His name was Martin Klaproth. He named it after the planet Uranus, which was discovered contemporaneously by William Herschel. 200 years later, a gentleman named Wilhelm Röntgen discovered ionizing radiation. A year later, you may have heard of Henri Becquerel. He put a piece of pitch blende on a photographic plate and it darkened it. And he was able to ultimately attribute that to beta emissions. What's that? Just electrons. and alpha emissions, just helium nuclei. And Pierre and Marie Curie later called that radioactivity, which is around us all the time now. It comes from the Earth's crust, it's in the planets, it's in the sun, it's in the galaxies, it's in the local medical machines that do your diagnostic imaging. But I digress. If I fast forward to the 1930s, Lise Meitner, Cannon, my colleague here, his most famous scientist, and her nephew Otto Frisch described the reaction as nuclear fission. And they described it as a nucleus coming together, or a neutron bombarding a nucleus, causing it to vibrate, split into two kind of equal parts. And what Frisch did was prove mass energy equivalency of Einstein's equation, E equals mc squared. He did verification, validation, and experimentation. So remember those two words, verification and validation, because that's the legacy that we own at Terrestrial Energy. Our scientists and engineers are verifying and validating our design, and I'll go into that in a minute or so. That verification and validation is inherent in the nuclear industry. It extends into the plant, but also back to resource extraction. If you follow a Canadian uranium atom, for example, just to illustrate the point, it comes from the northern mines of Saskatchewan, mined and milled into U3O8 called yellow cake, goes to a refinery in Blind River, northern Ontario, made into UO3 powder, sent to Port Hope or Peterborough, made into CANDU fuel in the case of Canada. Every step in that process, there's a verification and validation process. Count the atoms, make sure that they're safe and not creating environmental hazards. And that extends into plant operations as well. And you see plants operating, and our philosophy is very much akin to that verification, validation, experimentation, which you can see that as an example of our program there and all its vistas. And we take that very seriously. It is the legacy that we hold at Terrestrial Energy, but then it extends it into the rest of the industry itself, which on an international basis embraces these principles of nuclear safety culture. What we have done at Terrestrial Energy is take that legacy and turn it into the other two V's of nuclear, which is value and versatility. So remember the four V's if you remember anything else. Validation and verification, and in the case of Terrestrial Energy, value and versatility. This is a schematic of our IMSR technology. It was originally developed in the 60s in Oak Ridge, Tennessee, at the National Lab there. It was tested and validated and verified thoroughly. And we built on that technology, developing a commercial scale design, which can go into electric power generation and industrial heat applications, which I'll talk a bit more about. It's 195 megawatt, that core unit, and 400 megawatt thermal for those engineers in the room. The original design was 10 megawatts, so we've scaled it up significantly. What is at the heart of our innovation is our core unit, which is a replaceable sealed unit, replaceable every 7 years. You can see that the fuel salt, molten salt, it's a molten salt reactor, thermal spectrum, if that means to some folk, and graphite moderated. So the fission reaction happens at the bottom. The fuel salt flows upwards, pumped through a heat exchanger, and then it's separated into a secondary loop in the heat exchanger and sent to industrial heat users, or it can be sent to a steam turbine to make electricity. So our innovation has been built on that premise that every 7 years you replace the value of the machine, if you will. And we so far proven the economics to be able to work that way. Sorry. But value and versatility is our trademark now. And when we move into the Alberta marketplace, what we see is the opportunity to generate not just electricity, because, you know, Alberta's moved from coal to gas already in the electricity market. I was talking to one of the generators this morning. They want to maintain those assets. Nuclear might be in the future for them. However, oil sands and petrochemical companies here in Alberta, for example, are avaricious consumers of heat and electricity. And we have a solution that allows them to get both at low cost and carbon free. And this is a sample of our thermal electric facility. What you see in the foreground is the 2 reactor units, 190 megawatts each, 380, 400 megawatts electric, 800 megawatts thermal, and any combination therein of heat and electricity can be delivered to a industrial plant. So SAGD is an obvious one in Alberta, but there are other facilities, hydrogen production, ammonia production. We have just signed an arrangement with an international firm, KBR, to do ammonia and nuclear coupling, and they actually have some projects, one of them in Alberta. You can search it out yourself. So the industrial heat and power is a market for us that's been developed and taken off in the last 6 months because of energy security throughout the world, I would suggest. And we are promoting it in Alberta as a solution for emissions and emissions-free, low-cost energy. And some of what Mike tells me, he's my new best friend, creating electric power requirements that will help heat and generate you know, the value-added products that we look for out of oil and gas and petrochemical production. So in the interest of, I'm sorry, I lost my train of thought. I'm sorry about that. In the interest of our next steps here in Alberta, we are locating our offices here, by the way, so we are moving some of our operations from Toronto to Alberta in the next 3 months or so. We started to work locally with the companies. We see kind of 3 pinnacles of work to promote and start to resolve the myths within nuclear. One is the social values. What is the social acceptance of nuclear in Alberta? It's not in a nuclear province, and so it does not have a history such as Ontario. Secondly is what is the price and schedule for an Alberta build-out. Things happen in Alberta that don't happen in Ontario much anymore, which is construction of large, complex energy projects. The capability to do that exists in Alberta, doesn't exist in Ontario and other parts of Canada. So making an Alberta-based price, an Alberta-based schedule is important to us. Finally is the licensing pathway, which is important to nuclear. So we have the information to be able to deliver that licensing pathway, and our verification and validation, our versatility and value will deliver that for Alberta and for every other industrial segment in the world. So thank you very much.
Thanks, Bill. That was just about enough for me to understand enough about nuclear to be a little bit dangerous. So maybe we'll have to connect after so I can learn a bit more. So last plug for adding some questions into the Slido, slido.com, hashtag EDU breakout for your questions. Next up, we have Dayna Morgan. She is the COO and Innovation Designer, I love that title, at Britt Radius. Dayna has found that after 22 years with the company, she's now moved into an entrepreneurial role, which has really sparked her creativity. Dayna's hope for our energy future is that people and projects move forward together, approaching development projects holistically, where one is not at the expense of another. So let's hear from Dayna.
Thank you, and good afternoon, everyone. I'm here today to talk to you about the #1 hurdle to energy development projects today. Any guesses? Social risk, the human element of development projects that can so quickly enhance a project or put it into jeopardy. So I am Dayna Morgan, the COO of a ridiculously talented consulting services firm. We help organizations gain compliance and acceptance for projects that impact people and land. And I want you to remember those two words, compliance versus acceptance. We do that through navigating the intricacies of working with stakeholders, Indigenous communities, regulatory bodies, landowners, and it's an interesting space to be in. Our organization has done large public engagement events, working with communities, open houses, information sessions, right down to consultations required by regulation, and then into some of the most intimate settings, sitting across a landowner's kitchen table and negotiating for access to their land. So we've seen what works well and what doesn't. And what I'm hoping to share with you today is not only highlight the gravity of social risk, but also how to make it a little less scary, give you a bit of a framework on how to minimize social risk, and to inspire you to think differently from how it's always been done. So let's start by looking at what social risk is. As I mentioned, it's the human element. And for some, social risk can seem intangible, uncontrollable, uncertain, and it can be. I'm going to share with you a little bit today on how to make it less scary and make it a little more tangible. It relates to the social aspects that can put a project into jeopardy. The interesting thing about social risk is it can very quickly be turned into an opportunity and enhance a project. So why should we care? Why do you need to worry about social risk? With the emergence of an outrage culture, the voice of the public is stronger than ever. Coupled with the vast reach of social media and media, any development project is put under a microscope. And I'm sure we can all think of projects that have been in the news, major development projects that have had negative attention, negative public opinion. And you may also be thinking, well, that's just major projects. I don't have to worry about that for my project. In today's environment, any development, small or large, conventional or innovative, has a social risk component. And no longer are the days where we can go about checking a checkbox on an application and say we are compliant and all will be well. Stakeholders, the public, and Indigenous communities really want to be engaged more, they want to know more, and they want to be involved. Media and social media are obvious outlets for public opinion, and we're also seeing a transition in our regulatory frameworks, where there's a greater focus on how proponents, how applicants are engaging with the public and with their stakeholders. So between public platforms and regulatory processes, social risk is very much a material risk that's so great that project timelines can increase, additional costs can be incurred, and projects can be canceled altogether. Now, if we look at what's been done in the past in the energy industry, we've really taken more of an informed approach when it comes to working with our stakeholders. One-way communication, information is sent out, and we hope we don't get anything back. We hope we don't get any questions or concerns back. That usually leaves stakeholders feeling like they haven't been involved, they don't have an opportunity to ask questions, voice concerns, or provide support. When we apply more of an engagement approach, we really open up the opportunity to have more meaningful dialogue, build relationships, and gain trust with our stakeholders. And does this take time and effort? Yes, it does. And it usually happens at the start of the project. When you begin early, you can open up the opportunity to learn about potential hurdles earlier on and avoid those coming at the last minute when you're filing an application. So I'm going to share with you 5 tips for how to mitigate and minimize social risk and maximize social performance. The first one, have a plan. That seems very basic and simple and should be a no-brainer. What I want to share with you is that not every project is the same. Some projects require a more robust public engagement approach and others do not. So having a fit-for-purpose engagement strategy is really key. A valuable process that we go through with our clients at the start of any project is a stakeholder mapping exercise. And really that's looking at who could potentially be impacted by this project and who could influence our project. And what is that level of impact and influence? And what do they care about? What are they going to want to know about? Another key component to an effective engagement approach is being agile, being able to be nimble, learn what's working well, and pivot quickly. And I'd also encourage you to have your engagement strategy and your engagement plan be as important as your other project management plans, your quality management plan, your safety management plan. Treat your engagement plan the same. Second tip here is engage early. Engage early and often. And you may have heard this before as well. And what does that really mean? Engaging early is really just opening the lines of communication up with your key stakeholders or Indigenous communities to learn from them. And we often advise our clients the best time to do this is when you're still in the planning stage, when you don't have all the answers. And that's okay. The best way to gain trust and build rapport and relationship is ask for feedback. Ask for their questions early on. At this stage in the process as well, really listening to underlying values and interests is key to understand where concerns or objections may be coming from. Especially involving our Indigenous communities in the early planning stages is incredibly valuable. They know the land better than anyone and can be quite helpful in your planning and future development. Number 3, share the good, the bad, and the ugly. We often shy away from the parts of a project that may not be as favorable or downplay potential risks and hope they just don't come up in conversation. Think about a time when maybe you're being sold something and you're curious about the product and they're just telling you, don't have to worry about that. We've never had any problems. I don't know about you, but someone that doesn't know me, doesn't know my values, interests, my land, being told what not to worry about doesn't usually go over well. And don't wait until the questions are being asked. If you can anticipate what they may be concerned about, bring those forward on your own. The fourth tip here is understanding the difference between what consultation means and what engagement means. Consultation is typically a regulatory requirement. It's structured and it's a prescribed approach. It aims to fulfill the needs of the applicant or the proponent, whereas engagement is more strategic. It's two-way communication. It's fluid, it's dynamic, and it can support both the needs of the stakeholders and the proponent. And when done well, can really enhance your consultation process. The fifth tip, look beyond yourself. Coming up with an effective engagement approach means getting out of our own beliefs and biases. This energy diversification space or transition space is very exciting. You know, we look in this room and we're all like-minded people. We're excited about the opportunities, the new technologies, the new innovations that are happening. And I'd caution you not to allow your excitement to be put on others or create assumptions that they're going to be as excited as we are. An earlier speaker today mentioned the mystery of the energy transition space, and I like that word because for many stakeholders, the public, this is a little bit of a mystery. They're going to have questions. So being able to provide information, get them involved, educate is going to be really important. Also understanding what came before you, what precedents were set by previous industries or companies, what compensation was paid in an area, what was done before that is really shaping the landscape and the community and the culture that your project is now entering into. This is an area that our company is super passionate about, and we feel that there is a massive opportunity for those in this energy transition space to do things differently. So I hope today that I provided you some perspective on how to manage social risk, how to make it an opportunity, and work alongside engagement specialists to help you build a fit-for-purpose plan to help move the needle and get your project into compliance and acceptance. Thank you very much.
Thank you, Dayna. We're all going to come to the stage now, and I'm going to moderate a bit of a Q&A for the remaining time that we have. So still time to get them in. I think I'm going to take them in order of popularity, so upvote if you have access to the Slido. And if you don't have access to Slido but have a really burning question, feel free to like wave your hands in the air and we might take you up on the question. So thanks to each of you. That was all very different and very interesting perspectives to share as an entrepreneur. The first question is for Bill. What do you think about building nuclear plants underground to make them more attack-proof? Case in point, Ukrainian nuclear plant.
I'm not going to speak to Ukraine for sure. So part of our technology was halfway below the ground as well. So I think you see most SMR vendors are going deeper. Now there are some limitations. You find groundwater conditions that may affect that. The bedrock could be not stable enough, or it could be too deep to support the foundation. So it is, I think, embedded in most SMR designs as it is in ours. So it is an engineering assessment that needs to be undertaken because you need to consider other factors as well.
Okay, thank you. Thank you, Maggie, for the question. Mike, I'm going to put this one over to you, and then feel free, Dayna and Bill, to weigh in if you have something to add. But what aspects of permits, approvals, and regulations need to be changed in Canada to better support entrepreneurship in energy?
Wow. Thanks for that one.
Not a softball, but you got it.
No, I think the biggest thing is speed. I guess for us as an innovator, a lot of those processes, and especially in the energy industry, when you have, like Bill talked about, mega projects that take 5 years to plan and 5 to build, we can't wait that long. So in order to be able to enter that place, and it's something we've dealt with in trying to get our innovation into the oil sector, is how do you get that timeframe mindset to shift, both on the permitting side, but the permitting side then drives the culture of those companies. So they have to use them. So speed or a bypass route for innovation, that it's not big, it can't be that bad. If it's small, then find a way to triage and get things through faster so they can happen and we can get the benefits of innovation sooner.
Thank you for that. When I was thinking about questions of my own, since I have the power, I was curious to hear from anyone who has a response around like why Alberta or why Canada? Why is your technology or service going to be successful here? And I wonder if that's sort of related to sort of the permitting and the regulating. I've also heard for some technologies, of course, that does provide more of a barrier to get these regulations through the regulatory process. So I'm curious about sort of like the positive side of that. Like what is actually in place here that's helping you or has helped you get established? And if it's nothing, that's sad.
I'll take one.
Thank you.
So believe it or not, the Canadian Nuclear Safety Commission is a nuclear regulator, and they're actually quite progressive in the way in which they think. So I would say they've been a help. They're looking at technologies across a wide spectrum, and they're trying to adjust their approach to the regulatory framework to accommodate that. Now, there's other parts of regulation that I could spend 20 hours talking about that aren't working as well, but I would say the CNSC is working better than a lot. In fact, more innovative than you might expect.
Thank you. Dayna, I'm curious about your reaction to or opinion on the biggest challenges. Like you sound like you provide a service. I 100% agree with you about social risk being a huge risk to anybody who's trying to build a technology or a business. And I'm curious, what would be like the one ask you would have, or the one, if you had a magic wand, what would be the one thing that you would like to see happen in the ecosystem or in the energy transition that would support your offering?
Great question. I think something that's important for our company is, and it was touched on in the introduction, for people, the land, and projects to move forward together. We've seen a lot of development projects in the past where one of those is sacrificed for the other. So we're really encouraged by a lot of new organizations or existing organizations that are just taking a different approach now, where the people side of the project isn't an afterthought, that companies are being really proactive and taking that innovative spirit into the social aspect of projects. So I'm really encouraged by it, and that's where our company helps out. in a variety of ways, right from that strategic approach down to boots on the ground and grassroots kind of engagements and consultations. So it's an exciting space to be in.
Thank you. Bill, I have one for you, but just building off of that response. So the Energy Futures Lab focuses on what needs to exist in the system to have a technology adopted more quickly. And I strongly believe that what Dayna is offering and her company is offering is sort of one of those pieces that we need to flesh out and build out in the system so that the technologies of the other entrepreneurs at Energy Disruptors and beyond could get adopted more quickly. So I support that, and we're very aligned from the Energy Futures Lab perspective. Okay, Bill, this may be an easy one, I'm not sure. How long does it take to go from a proposal stage to an execution stage for a nuclear project? And does it vary by province? How do timeframes compare worldwide, if you happen to know that as well?
So historically, and traditionally, it's been known as a very long time, 15 to 20 years. I mean, I worked at Bruce and Darlington myself. Those projects went over a period of 25 years in some cases. So that clearly is not acceptable for an energy transition. You can't get to, even 2030 and hope to be there by 2050. So there needs to be some change. One, there needs to be a market demand. That's what Alberta offers, is a demand because there's industrial heat load and there's a demand to get zero emissions down. So now energize the politicians and the decision makers at the policy level to find ways of cutting through some of the red tape that does exist. As I say, the CNSC has offered us a vendor design review. We've been able to partake of that. That prepares us for the next stages of implementation. But then there is a whole host of others, and people in Alberta know that, from Ministry of Oceans and Fisheries to Transportation, and the coordination amongst them is up to the project proponent. So it does take, best case, 2 years licensing, 2 years of other licensing. That's 3 to 4. While you're doing that, what we do well is design, research, and license the plant, and this in parallel. It takes you 4 years to build the first one, so it's best case 8 years from license to grid online.
And that's Canada-wide?
It would vary, I'm sure, and there's been no real test other than Ontario recently, so we're going to test it out in Alberta.
Okay. Thank you. I imagine your magic wand ask would be to reduce that time dramatically?
Yes?
Yes, okay. Mike, a more technical question for you. How do you compare to fossil fuel boilers in regions with high carbon intensity power?
That's a good question. I guess I would have to know how much, how carbon intense. Certainly that's a big factor. I guess, in the specific boiler space, a lot of what we think we could do where we could bring an advantage is more of, like you might have at home, a residential flow-through heater that only heats the water as needed. So instead of heating all that water all at once, we would heat it at a much larger scale, delivering a mass amount of energy to it as it moves through a larger pipe. So you're not using all the energy to maintain it. That would help to increase the advantage versus if you're using high carbon power. But that's always going to be a question in the equation. We'd like to believe that the intermittent ability to then dump that heat in, not run it 24/7, would then either help manage the greening of the grid or encourage or finance some investment in a cleaner source of power, because you'd know where you could put it off peak and then probably sell it, at least in Alberta or places with that kind of capacity.
Okay. I love how I nod that whole time, and I'm not quite there on the technical understanding, but it sounded very smart. So whoever asked the question, I hope that answers it sufficiently. As we're running out of time, I have one final question for everybody. Julie, this includes you. We do this in the Energy Futures Lab at the end of a session. What's a one word that you would check out that you'd like to leave the audience with? One word. We'll go in order. It's just easy. Bill?
Versatility.
Dayna?
Opportunity.
Mike?
Decarbonisation, efficiency. I got 2.
Okay.
A lot of syllables.
There's always one. Again, Julie?
And curiosity. What's yours, Erin?
Oh, power. Just with the 15 seconds, I do want to do a quick plug. The Energy Futures Lab is a fellowship-based model for solutions, identifying solutions for energy transition. And the fellowship's open, applications open in October. So we're looking for more entrepreneurs and more diversity in our fellowship. Please apply. Talk to Julie and I after if you want more information. Thank you.